Hey everyone, welcome back to CodeChunk. Today we are diving deep into creating an ERC20 token from scratch using Foundry. USDT, USDC, DAI, UNI, these are all ERC20 tokens running on Ethereum. What exactly is ERC20? It's a standard, a set of rules that all tokens on Ethereum follow. Think of it like a blueprint. This means any wallet, exchange, or DeFi protocol can work with any ERC20 token without custom code. So, in this video, we're going to build a complete ERC20 token contract from scratch, understand every single function and why it exists, write comprehensive tests using Foundry, deploy it to a local blockchain of Foundry, and I'll explain the why behind every design decision. We're using Foundry because it's fast, uses Solidity for testing, and gives us powerful tools like fuzzing and gas reports. And of course, it's built on Rust, which is fantastic. By the end of this tutorial, you won't just know how to copy-paste code, you'll understand how ERC20 tokens actually work under the hood. So, let's get started. Before we write any code, let's understand what ERC20 actually requires. ERC stands for Ethereum Request for Comments. It's basically a proposal that becomes a standard. ERC20 defines a standard interface, 6 required functions that every token must implement. Let me break them down real quick. First is total supply. This function returns the total number of tokens that exist. Simple getter. Second one is balance of, which tells you how many tokens a specific address holds. This uses a mapping internally. Transfer sends tokens from your address to another address. This is the basic send function. Now here's where it gets interesting. Approve lets you give permission to another address to spend your tokens. Think of it like giving someone a credit card with a spending limit. Next one is allowance, which checks how many permission was given, how much can that spender still take. And finally, we have transferFrom. This is how the approved spender actually moves the tokens. This is what DeFi protocols use. You approve a DEX to spend your tokens, then it uses transferFrom to execute the swap. There are also two required events, transfer and approval. Events are crucial. They're how wallets and block explorers track token movements off-chain. Optionally, you can add name, symbol, and decimals. These help with display. Most tokens use 18 decimals, matching Ether's precision. Now, why does this matter? Because every wallet, every exchange, every DeFi protocol knows these 6 functions exist. They can interact with any ERC20 token with custom code. That's the power of ERC20. Now that we understand this standard, let's build it from scratch. We'll see exactly how each function works and why it's designed this way. Let's get Foundry set up. You'll need basic Solidity knowledge for this. If you're watching this, you probably have this covered. So, Foundry is a blazing fast development toolkit written in Rust. Unlike Hardhat or Truffle, you write even tests in Solidity, not JavaScript. It has become the go-to tool for serious Solidity development. Installation is super easy. I leave that to you. Just go ahead into the documentation of Foundry and you will find installation super easy. So let's verify if it's installed. Forge -- version. As you can see here, we have version 1.1 stable. So let's go ahead and create our project. Forge init ERC20 token. Perfect. Foundry created a bunch of stuff for us. Let me show you what we have. First, in SRC, this is where our contracts go. You'll see a default counter.sol. So we'll delete that. Let's go ahead and get rid of it. Our test files go here. Tests are written in Solidity, which is awesome. As you can see, but we need to get rid of it for now. The third directory is a script, which deployment scripts live here. We'll create one to deploy our token. Let's get rid of it as well. And finally, the important thing we're going to mention is foundry.toml file. This is the configuration file. We can tweak compiler settings and remappings and more. The default settings are usually fine, but we might adjust the Solidity version later. Perfect. Now we have a clean slate. Let's build our ERC20 token. So let's go ahead and create our token. I've created a file called token.sol. You can name it whatever you want. First of all, we're gonna specify our identifier. This identifier is required by most compilers, and we need to write it at the top of our Solidity file right away. We're gonna use pragma. Pragma sets our Solidity version, in our case, version 0.8.0, and all above versions, which gives us built-in overflow protection. Now, let's declare our contract. So I'm going to say contract, let's say ERC20 token. Inside the contract, we need state variables to track our token data. Let's add them. First of all, we have a mapping, which is address to uint 256. Let's say it's private and it's going to hold balances. So think of mapping like a dictionary. It maps addresses to their token balances. Private, as you can see here, means only the contract can access it. So we're not going to use mapping directly from anywhere else but contracts. We're going to provide instead public getters to get access to balances from outside of our contract. The next mapping we're going to need is going to be address to mapping of address to uint 256. This one's gonna be private again, and it's gonna be our allowances. This is a nested mapping. Addresses mapping to other addresses mapping to amounts, right? This tracks allowance. How much can address B spend from address A's balance? This is how approve and transfer from works. The next thing we're gonna do is total supply, which is the total number of tokens that exist. We'll set this in the constructor. Finally, we have a bunch of public state variables. First one is going to be a string public name, string public symbol, and finally uint 8 public decimals. These are public. Solidity automatically creates getter functions for them. So name and symbol are self-explanatory. Decimals is usually 18. That means one token is equal to 10 to the power of 18, smallest units, just like Ether and Way. If you don't have any information about this, I will leave some links below in the description, so make sure to check them out. Now let's go ahead and create our constructor. So I have my constructor like this. We're gonna get a actually name. We're gonna get a symbol and a uint 256 of initial supply. We're gonna set name to this name. We're gonna set symbol to underscore symbol. And finally, we're going to set decimals to 18, which is the standard. Finally, we're going to mint the initial supply. So we're going to say our total supply is going to be initial supply multiplied by 10 to the power of decimals. Then we're going to set the balances, and we're going to set the balance of message.sender, which is someone who is initializing the contract, and we're going to set that to be equal to total supply. Finally, we're going to emit our transfer event. We're going to set address 0 to it, message dot sender, and finally we're gonna pass total supply. So as you can see, we multiply initial supply by 10 to the power of 18 to account for decimals. Then we give all tokens to message.sender. That's whoever deploys the contract. We emit a transfer event from the 0 address to the deployer. This represents minting. That is our core structure. We have storage for balances, allowances, and metadata. The constructor mints the initial supply to the deployer. Next, we'll implement the required ERC20 functions. First function we're gonna write is total supply. So let's go ahead and say function total supply is gonna be a public function. It's gonna be of type view, and it's gonna return a uint256 variable, which is gonna basically return total supply. That's it. It's just a simple getter. View means it doesn't modify state of the blockchain. It's free to call, returns our total supply. Next, we have balance of function balance of. We're gonna take an address, which we're gonna name it account. It's public. It's gonna be of type view, and it's gonna return a uint256 again. And it's gonna use our mapping of balances, and we're gonna return this account's balance. This is basically another getter. It takes an address, returns their balance from our mapping. That's it. Now, the first function that actually does something is gonna be transfer. So we're gonna use function keyword again. We're gonna take an address called to. We're gonna say uint256 amount. It's gonna be a public function because everyone's gonna use it, and it's gonna return a boolean. So first of all, we have address of owner, which is message.sender, who is whoever that calling our transfer function. Then we're gonna say transfer owner to an amount, and then we're gonna return true. So we get this sender, we call an internal underscore transfer function and return true. ERC20 requires returning bool, though most implementations ignore it. So let's go ahead and create our transfer function ASAP. So inside transfer function, we're gonna get an address from, an address to, and a uint256 of amount. This function is gonna be internal, which means it's gonna be only be called directly from within our contract. So we have two conditions for this function to work. We're gonna use require keyword in Solidity to create conditions, just like if, right? So we require from not to be address 0, which means ERC20 transfer from the 0 address. So we're basically saying that if from address is gonna be address 0, then return with this error message, ERC20 transfer from the 0 address, which is not actually valid, which is a address that doesn't exist. And the second condition we need is to address to have the same situation. We need it to be not equal to address 0. If it is, return with a message of transfer to the 0 address, which is gonna burn actually all our tokens. This is something most contracts do to burn their tokens. So 0 address checks. You can't send from or to the 0 address. That's invalid. Then, if these two conditions have been met, we're gonna go ahead and continue with our transfer function. We're gonna say uint256 from balance. So first of all, we're gonna get balance of the user, which is gonna send some token to the to address. And then we have another require statement. We need this from balance to actually have that balance to send to address, right? It's a bit complicated, but I'm sure you'll get it. So we require from balance to have more or equal amount to this sending amount. And if they don't have this much, we're gonna return with a simple error called ERC20 transfer amount exceeds balance. Or we can just go ahead and say not enough balance. And finally, we're gonna send the tokens. So balances from is gonna be from balance minus amount, and balances to is gonna be balances to plus amount. That's gonna be it. But since we have checked for these conditions, we can go ahead and wrap these two things inside unchecked. Okay? We already checked for the overflow, right? So we can skip the check for gas savings. Perfect. Finally, last but not least, we're gonna emit transfer again from to amount. Make sure to emit this transfer. This is crucial. Wallets and block explorers listen to these events every second. Now the next function we're gonna implement is gonna be approve. In here, we're gonna take a spender and a UN256 amount. It's gonna be a public function which returns boolean. It's not gonna be view because we're actually gonna be changing the state of blockchain. So we're gonna first of all say address of owner is gonna be message.sender, and we're gonna call approve, and we're gonna pass in owner, spender, and amount, and finally return true. Now it's time to implement our approve function, which is gonna be an internal function. So we're gonna take an address owner, address spender, UN256 amount, and it's gonna be internal. So we're actually delegating to an internal function here. This sets how much the spender can take from the owner. So we have two checks again. First of all, require owner is not address 0. You know the drill. ERC20 approve from the 0 address. Then we have spender have the same situation here. There we go. And finally, we're gonna change our state of blockchain by changing our allowances. So allowances of this owner of this spender is gonna be amount, which means this spender has the permission to spend this much amount of our token from this owner. Finally, we're gonna emit another event called approval, and we're gonna pass owner, spender, and amount. So quick summary of this approve function: 0 address checks, set the allowance in our nested mapping, emit event. Finally, we're working with allowances, so let's go ahead and create a getter function called allowance, which is going to take an address of owner and the address of spender. It's going to be public view returns UN256, and it's going to return allowances of owner of spender. Now, the big one, the transfer from. This is what DeFi protocols use. We're going to use a function called transferFrom. It's going to take an address from, address to, an amount. Public returns bool. So we're having an address of spender, which is message.sender. We're gonna spend allowance from spender an amount, we're gonna transfer from to amount, and we're gonna return true. Now let's go ahead and implement our spend allowance here. So I'm gonna say there is a function called spend allowance. It's gonna take an address of owner, an address of spender, and a uint256 amount, which is gonna be internal function, which means it's gonna be only called directly from within our contract. So uint256 current allowance, which is the current allowance of this spender, allowance, owner, and spender. So if current allowance is not of type uint256.max, I'm gonna explain it, don't worry about it. We're gonna require current allowance to be equal to amount. Otherwise, we're gonna return with a simple error called insufficient allowance. And finally, since we have checked for this, in an unchecked block, we're gonna go ahead and say approve owner spender current allowance minus this amount. This function actually handles the allowance logic when someone uses transfer from. First, we get the current allowance, then we check for the type of uint256.max. It's the maximum value a uint256 can hold, basically infinity for our purposes. Here's why this matters. In DeFi, users often approve tokens once and then make many trades. Instead of approving 100 tokens, then 200 more, then 300 more, which costs gas each time, users can approve type uint.max once. That means you can spend as much as you want from my balance. So in this function, if the allowance is infinite, meaning it equals to type uint256.max, we skip the check and skip decreasing it. The spender can use any amount they want, and the allowance stays at max forever. If the allowance is not infinite, like 1000 tokens, we check that the spender has enough allowance. Then we can decrease it. If they are spending 300 tokens, we subtract 300 from the allowance, leaving 700, right? So this is a common pattern. Tokens like USDC and USDT support it. It's why when you connect to Uniswap, you might see an approval for an impossibly large number. That's the infinite approval pattern. We call underline approve to update the allowance, which also emits the approval event so wallets can track the change. So we need to declare our events at the top of the contract finally. We have two events that we are going to create. So the first one is going to be the transfer event. It's going to take an address of from, which is indexed, address indexed to, and uint256 value. We have the same thing, but instead of that, we have approval, we have owner, we have spender, and value. That's gonna be it. Indexed means these parameters are searchable in event logs. That's why wallets can track your token balance. That's it. We have all our events and 6 required functions. Now let's go ahead and test everything out together. Time to test our contract. In Foundry, tests are written in Solidity. Let's create inside test, let's say my token.sol. Same things again. We have SPDX license identifier and our Solidity version. Now let's import test and console from forge std/test.sol. It's a file that we need to test our contract. It's coming from forge.std, which is the package installed within the Foundry project. It's gonna be installed automatically when you initialize your Foundry project using Forge. Perfect. The next thing we're gonna use is to import ERC20 token, which is coming from src token.sol. Let's go ahead and say contract. My test token is test. This is how we tell Foundry that this is a test file. First of all, we're gonna create a token. So ERC20 public token. This is the newly created token, which is of type ERC20 token. Then we have our address. Which is public owner, which is gonna be address 1. You can build addresses like this in Solidity test files in Foundry. Then we have address public user 1, which is gonna be address 2, and public user 2 address 3. So as a summary, our test contract is inheriting from test. We'll create test addresses like this. In Foundry, we can use any address. No need for real accounts. This is just 1, this is 2, this is 3. You can use any number you want. Next up, we're gonna have a function called setup. This is gonna be a public function. Inside here, we're gonna use vm.prank, and we're gonna pass in the owner, and the token is gonna be new ERC20 token. So first of all, we're gonna pass a name, a symbol, and initial supply. So in here, let's go ahead with test token TT, and finally let's go with 1,000 of initial supply. So this setup function runs before each test. vm.prank makes the next call appear to come from the owner. So when we say vm.prank owner, it means this line is gonna be called by owner. So now let's create our first test. We're gonna say function test deployment. It's gonna be a public function. So what do we need to check? We first of all saying assert eq token that name is gonna be test token, right? Then we're gonna use assert eq token that symbol equal to TT, as you can see. Finally, we're gonna say assert eq token dot total supply is gonna be 1,000 multiplied by 10 to the power of 18. So this is our first test. We verify deployment. Assert eq checks equality between two variables, and all initial supply should go to the owner. So inside our first test, let's go ahead and say assert eq token dot balance of owner is gonna be equal to this initial supply. So all initial supply should go to the owner. Now let's go ahead and test our first test. We're gonna say forge test. There is an error. Let's first add T here. It's the best practice for writing Solidity test files in Foundry. And finally, we're gonna change our directory, right? Forge test. There we go. We have one pass, which means our deployment was successful. Perfect. Now I'm gonna write 2 more tests, and I'm gonna leave the other tests for you guys to actually learn something and go and explore. You can use even AI to write tests for you. The next one I'm gonna write is exactly this test transfer, which is gonna be a public function. Okay, So we're going to use vm.prank of owner, which means the next line is going to be called by the owner. So token.transfer to user1. How much? 100 tokens. How much? 100 tokens. Okay? So we're going to use decimals again. And finally, we have ZERTEQ of token.balance of owner to be equal to 900, right? Because owner just transferred 100 tokens to user A, right? And we have the exact same thing for user A with this different that is going to be 100, right? User A just received 100 tokens. Let's go ahead and say forge test. And as you can see here, the next one is passed as well. Now, let's go ahead and create a test file, which we are gonna expecting an error of, right? So, function test transfer insufficient balance, which is gonna be a public function. Now, we're pranking user 1, which means the next line that we are going to write is going to be called by user. But before making the call by user 1, we're using VM again. So we're saying expect revert, which means the next line, which is going to be called by user 1, we expect that to throw an error. Okay? So what is the error we're expecting? We're expecting ERC20 transfer amount exceeds balance. So let's go ahead and say transfer to user 2 1,000 tokens. Okay, we expect this to revert with an error of transfer amount exceeds balance, because look, user A has only 100 and is trying to send 1,000 to user 2. Let's go ahead and say forge test. So let's explore and find out what the problem is. So in here, quick debug note, we can use forge test dash dash match dash test, and in here we're going to use this keyword to only test one test function. So I'm going to paste this in, which is what we are going to test. And then I'm going to use -vv, which means run test with full details. Okay, it's perfect for debugging. So as you can see here, the error is not equal to expected error. So we're getting not enough balance, which is not equal to ERC20 transfer amount exceed balance, right? So if we go to token, as you can see here, we require from balance be equal or more than amount, and if not, we're returning with this error. Okay? The errors are not the same. Let's paste this in. Let's clear our terminal. Let's forge test now. And as you can see here, it's passed. Perfect. Forge test again with all tests. As you can see here, we have 3 tests passed successfully. Now, as the final step, let's deploy our token to a local blockchain. Foundry includes Anvil, a local Ethereum node. In order to use that, just open up your terminal and type in Anvil. As you can see here, we have a fully customized blockchain that we can use to deploy and test our contracts on. You can see default accounts with private keys and 10,000 Ethereum each. So notice the RPC URL, which is gonna be localhost 8545. We'll use this to deploy our contract, and we need to keep Anvil running in this terminal. So what I'm gonna do is to create a new file called deploy.s.sol, we have the same thing from the test file. Instead, in here, I'm going to use script and a script. Okay, this is how we tell Solidity that this is going to be a script file. So let's go ahead and say contract deploy is script. And in here, we're going to have a function again. The function is going to be run, which is a public function. And in there, we're going to use something called vm.start broadcast. This line actually records transactions on the blockchain. Now it's time to create our token. So let's say ERC20 token new ERC20 token. So test deploy token TDT, and the initial supply is going to be 100 again. Now let's go ahead and import ERC20 again. Let's create a bunch of logs. Console.log token deployed at address of token. Console.log total supply token dot total supply. And finally, console.log owner balance token dot balance of message dot sender, which is going to be actually our owner. And finally, vm.stop broadcast. That's it. That's how we're going to deploy a token to a blockchain. And we have a typo here as well. Function run. That's it. And here as well, our script is good to go. Now, how can we deploy it? We're going to go ahead and use bash or a terminal to deploy our script. So we're saying forge script slash deploy dot s dot sol dash rpc url. We're going to use http localhost 8545, which is the RPC URL of Anvil blockchain. And finally, we're going to say -- broadcast. Oops, we're in the wrong directory again. So let's cd to ERC20. Now, let's go ahead and deploy our script. So as you can see here, we're getting an error. You seem to be using Foundry's default sender. Be sure to set your own sender. Okay, we're gonna do that. But here we have total supply and owner balance equal to a very large number. That's because this 1000 is gonna be actually multiplied by 10 to the power of 18. Now, if you go ahead and instead do token.total supply divided by 10 multiplied by 10 to the power of 18, we will get another number, which is gonna be this, exactly equals to total supply, which means it's gonna be working, right? And we're gonna do the same thing for message.sender, actually balance of message.sender, which is balance of owner, which is gonna be 1000 tokens, which means our contract is deployed successfully. So to get rid of this error, which seems to be a warning basically to me, let's go ahead and use -- sender, or better to use -- private key. And let's use this account's private key, which is not default account. The default one is going to be this first one, this address basically, and this private key related to this address. And let's deploy our contract using this account. And as you can see here, perfect, on-chain execution complete and successful. Now, this is our contract address. We need that. We need that to interact with our contract within our Bash terminal, right? So let's interact with our deployed contract using Cast. Cast is another powerful tool that Foundry lets us use it in order to interact with our deployed contracts. So let's go ahead and say Cast call contract address. Let's say total supply. This is how we're going to call a function using Cast, which exists inside our deployed contract. Dash dash RPC URL HTTP localhost 8545. So as you can see here, we are getting this large hex value. This one actually calls a view function, and you're going to see the result in hex, and that's totally normal. Now, in order to convert it to a normal value that we can see, we're going to use cast dash dash to des, and we're going to paste in this hex value. Now, as you can see here, we have the same amount when we ran the deployment script without this division, right? Which is going to be perfect. This is perfect, and it's returning the total supply correctly. Now, let's transfer some tokens. We need a private key from Anvil. So let's go ahead and do that. So let's go ahead and say cast send. We're going to paste in the contract address. Then we're going to say transfer address uint 256. These are the type of parameters that transfer function gets. Remember, in here, if we go to transfer, where is it? As you can see here, we're taking an address and a uint 256, right? So inside here, let's send some tokens to this account, So we're gonna send some to this account, and we're gonna send, let's say, 100. So this is 1000. This is 100 tokens, and we're gonna say dash dash private key. We need the private key of message.sender owner, actually, which has 1000 coins or tokens, to be honest. Dash dash RPC URL HTTP localhost 8545. Let's go ahead and do that. Okay, status is successful. Now we're gonna check the new balance by cast call contract address. Let's see, what was the contract address? I believe this was the contract address. Let's say balance of, which takes an address. So we send tokens to this address. Dash dash RPC URL HTTP localhost 8545. And as you can see here, we have this. Let's cast it to des, and as you can see here, we have the new balance, which is 100 tokens. Perfect. We have built a complete ERC20 token, tested it, deployed it, and interacted with it using the powerful tool called Cast in Foundry. You now understand how ERC20 tokens work, how Cast work, how deployment scripts and tests work in Foundry. So we have covered a lot. Let's recap what we built. We created a complete ERC20 token from scratch. We implemented all 6 required functions. We added proper error handling and 0 address checks. And finally, we learned how to write tests. And you have a task, by the way. Go ahead and complete our tests to learn something from this course. And finally, we deployed to a local blockchain called Anvil and interacted with it perfectly. More importantly, you now understand how ERC tokens actually work under the hood, why each function exists and how they interact, the approve and transfer from mechanism, the foundation of DeFi, how to test smart contracts properly, how to deploy and interact with contracts. All the code is available in the repository. We have the link in the description. Feel free to use it as a starting point to your own contracts and tokens. So that was it, guys. If this helped you, hit that like button and subscribe for more Solidity content. Drop a comment if you have questions or want to see something specific. Thanks for watching, and I'll see you in the next one.